Okay. If you have everything set standard, which is never standard, you then can also make changes. So I'm going to point out what we have done here. We have made sure that I'm going to options, to profiles, that we've kind of set something current. We have a screen here. Our check is file new. You've got something set here. You need to know, no matter what, when you start on a drawing, you need to check your units, type units, understand what you've got there. Remember, there's all kinds of different ways. One of the things that might be useful in here is to deal with radians as well, which direction is north, etc. The scale of content may or may not be of importance. I like to really think about it more in terms of unit lists, but this has to do with some of the stuff coming in. If things are off, they'll be off by 12. In terms of this, learning that lines have direction and to learn how to get line types that show direction is probably a useful thing. Line types typically are, you're going to see up here on tier that you want to make sure there's a pull down up here for menu bar, right? Menu bar. So show menu bar. You never want to lose the menu bar. I don't care what program you're in. And then eventually format. You have all kinds of things here, but line type is your format. And you see here that I've got a lot of line types in here because I loaded them in. Where do you load your line types from? Well, wherever you get them, from the web. Or for sure, load them up from a standard place on the standard drive, standards Autocad. Line types, in this case, ACAD Force. It's giving me all kinds of line types, and the reason why I'm using those line types is because, in fact, they have been defined already, and in fact, they're going to give me some text that shows me the direction of the force. And arrowhead is also good. Autocad does not have this out of the box, and I won't put it in there in the short term because it's too much to carry around. Eventually you will see what you're going to want to be doing for a lot of these things is to bring in scaled blocks, with one of the scales being the magnitude of the vector. It gets you back to this concept of every vector being a magnitude times a unit vector. The unit vector describes eventually the position and the direction. In other words, the point of application. I'm going to hit OK here. I've got lots of these set. I'm going to load up 10 force, OK. And I'm going to reload timeline 4. I'm going to hit OK here. And I'm going to now go through, and for the first time, I'm going to be changing my line type based on the forces. So they're all going to be object. It would make a lot more sense to make, at this point in time, a layer or a layer called forces, but I'll leave it on object. I'm going to go here. I'm going to draft one, just arbitrary again. You notice how that came in. It came in with something showing me the direction of it. If you remember, there's going to be a lot of things in terms of going over the top here. Delta X, delta Y, delta Z is eventually going to be an important concept, but we're talking about 2D vectors here. So I've got one there. I'm going to go back to my line type here and not change that. I'm going to change that back to continuous. And for the first time, you're going to get used to this, then changing right-click properties or having the style bar up, right-click properties or quick properties, and changing that to a line type of 10 force in this case. You see all the data that's coming up there. Line type, we're going to pull it down to 10 force. That's basically what? The force that's got a number describer called 10. I'm going to add another one here. Same general bit. That is another force vector. And then a third force vector that is not concurrent with the other two. This one I will change its properties. Right click. Properties, change its line type to 11 force. And I will change this line type to right click. Properties to 12 force. Later on, 10, 11, 12, and it's a good idea just to keep track of this as we go through, to take that and right-click, change its color to not by layer. I'll make the first one red, the second one yellow, and you notice in this case I am not changing them. I'm changing the color, not the layer. Alright, how do you go around adding vectors? You slide them to a point of concurrency. A point of concurrency is to be the point where they visually intersect For grins, I'm going to go ahead and put a guesstimate on it right around there. And now let's talk about how you can go about doing this by adding points and then sliding things along lines. So, draw here, I'm going to put a point, and now this would be the time that you really want a point where you can apply from here and here and get it. It's not set up that way. If you turn on O tracking and O snap, it should start to grab some direction if things are set. Right there you see how it's grabbed that center, but that's not what I want. I want to get an extension. So in O tracking you have an ability to go through and do this. Shift right click, object snap settings, object snap tracking. Extension would be a really important snapping track to have on. Maybe the rest of these are not. And let's see what I can do now as I go line here. See how it's getting that extension here? If I go to here, it's got an extension there and it finds that point. So realistically, you can very quickly find points of intersection without going through the process that you do on paper of going through. So let's double check that we know how to do that, because I'm not a big one on this, but this is in effect pretty useful. Now I don't need that. And I'm going to tell you it's still going to be worthwhile sticking some points here. So we have a directionality to that. We have a directionality to that. And now that case will be that I want to find this intersection point. So I can more or less drop in a point. And that point is now going to be, you want the extension of that and the extension of that. And when it finds it, I drop in that point. Now I now have a point, and we can slide all these vectors now. Left click. Hitting escape here. Left click space bar, move to the shift right click, the node if you want to set that up as a node. And realistically you're going to take this left click space bar, move. You're going to take it to that node, but you really don't want to leave it there because that's not necessary. That's so you can see that's actually what you're doing. You're not allowed to slide something off of its line of action. You're just doing it mathematically. I take this now to the endpoint. And now I have essentially, in a second, the addition of these two forces. I'm going to zoom 0.5x. I now can draft this one. If I really want to keep track of the first one, I can take this one, take it out to the endpoint there. And I have those two as being my 2 points. If you notice there, I had that point of intersection that was there. I now have a force that's going that direction and a force that's going that direction. Our point of intersection will be someplace here. Let's see if we can do that again. I can drop in a point. Remember, you have the snap extension on, and that means if you hover and go, it will find that point. You stick that point there. You now shift these things so they emanate with their tails from that. You're going to do this by left click space bar. You're going to move that to the node. Same thing here. You have to know which direction that's going. We'll play around with the font sizes. So you want to move that one. Left click space bar. You're going to move it to the node here. And the node isn't what you want. You want to get it now to there to start, but then immediately to the end point of that. Now this force turns into that force. So in effect, you can pull this, drag it around, right click to the endpoint there. You now have, in fact, what is the resultant of the three forces you started with. That's it. So good skills here, realistically on a sheet of paper, using implied directions, starting to use O-track, O-snap. You can buzz through a lot. Much of this is superfluous. In fact, that you have to know that what you can do is add up all the forces, add up all the moments, and then place a force on the plane along a line of action that will give you the same moment as the sum of all the other moments. You will see that what's beautiful about this is these lines have now some information attached to them that they will all be forces, but they've got different coding, both color-wise and line type-wise, that you can start to differentiate and go with them. You will have to realize that the concept of area underneath a curve that is going to have one axis that's not left and right, but one axis that is distance and the other one that is pounds per foot. Therefore, you get pounds or kips is going to be important. Thanks for listening. Give this a try. Sliding vectors, adding vectors, tip to tail. making any two coplanar vectors concurrent, because they are, and then doing two vectors at a time should be fast, should be slick, and in AutoCAD it becomes not only fast but exact. Thanks for listening.